Through the OONI Explorer search tool, we can explore which websites are blocked around the world. To do so, access the search page of OONI Explorer. Through the search page, as mentioned, we have various parameters based on which we can filter all of the measurements collected from around the world. To limit our search to only those pertaining to the testing of websites, start off by selecting the options under Test Name, to then choose the Web Connectivity test under Websites. Once Web Connectivity has been selected, we can then click Filter Results in order to limit our results to only those pertaining to the testing of websites. We can now see that all the results that we have are only collected from web connectivity measurements, testing various different types of websites around the world. Each of these rows represents a different measurement. By clicking on the row, we can access the actual measurement. Quite similarly to the OONI Probe app, we can see that a test result starts off by presenting an overview of the finding on the top. In this case, we can see that Instagram.com was tested in South Korea on this specific network in this specific moment in time on the 31st of March 2022 at 10 a.m. UTC. From the green banner and also from the tick and the OK, we can understand that this test result was annotated as OK. We can understand that when Instagram was tested in South Korea in this moment in time, that based on OONI's methodology, it was found to be accessible. By scrolling down on the measurement page, we can find more details to learn exactly why and how OONI Probe determined that Instagram was found accessible when tested on this network in South Korea. To understand the measurement page, it's useful to think about how the OONI Probe test works for measuring the blocking of websites. If you would like to have a fresh reminder, you can click on Web Connectivity over here in order to read a detailed description of how the test works and how, from a methodological perspective, it attempts to measure the potential blocking of websites. Some essential things to remember about the specific methodology is that it tries to perform both an HTTP and DNS experiment automatically from two different vantage points. These experiments are performed on the one hand from your local network. So in this case, it was performed from this specific network in South Korea. But the experiments are also performed from a control network, which is a non-censored network. Then the results are automatically compared, and if they match, then the tested website is considered to be accessible. If, however, the results from your local network and from the control network differ, then that may be flagged as an anomaly, indicating the potential presence of censorship. By scrolling down further below, we can view more details. First, what the Web Connectivity test does is that it does a DNS lookup in order to identify which IP address is allocated to the specific website that we want to test. In this case, we can see that for Instagram.com, we got back this specific IP address. And once we got back the IP address, we tried to connect to it. And as we can see, the connection to this IP address was successful. Once we were able to connect to the IP address of Instagram, we then performed an HTTP request where we requested to get back the content for this specific URL, for Instagram.com. And if we scroll down, we will see the HTTP response, where through the response, we can see that we got back the actual content of the page. And so this is what shows us that Instagram.com was actually accessible from the specific network in South Korea, and that users on this network should be able to access this website. If we scroll further below, we will be able to also find further information such as, for example, some of this metadata over here. This metadata includes a report ID, which helps us to identify the specific measurement and, for example, retrieve it from the OONI API. We can see on which platform the test was run. In this case, it was run on macOS. We can also see that it was run on OONI Probe Desktop and in an unattended way, which means that this measurement was collected through automated testing. And we also list the specific version of the OONI Probe measurement engine that was used for this testing. Further below in the measurement page, you can view the raw measurement data. Now, the raw measurement data is what provides us this rich insight into how the testing was performed. And if access to a website is blocked, this is a type of data that can potentially serve as evidence. You can download the raw data in JSON format, or you can view it directly in here. The information provided earlier above provided a summary of some of the key points based on this raw measurement data. So to explore this data, you can start off by expanding the test keys option. And then as you scroll down, you can get detailed information from the HTTP requests, from the attempts to connect to the IP. We can see that from the DNS lookup, which if we extend over here, that we try to get back the IP address for Instagram.com. We tried to connect to this, and once we connected to it, we got back in the response the content hosted on Instagram. And so here we can just find all the detailed information that is summarized also above in this measurement page. So in summary, in every measurement page, the way that they are structured in terms of information layout is that you have a summary of the basic finding on the top, and then the further down you scroll on the page, the further details you have. In the beginning, you have summary information based on the DNS lookup, the attempt to perform a TCP/IP connection, and also from the HTTP request. And if you want to explore further, you can access the raw measurement data towards the end of the page, and you can also download it in raw JSON format. So if we want to have a look at which websites are blocked in the world, how do we do that? Well, for starters here, we have not selected any particular country, so we're going to try to see which websites are blocked globally. To do that, we can select the confirmed option under status, and remember that confirmed only applies to the testing of websites. Confirmed means cases where the blocking of websites is automatically confirmed. And there's essentially two cases when websites can be automatically confirmed based on OONI's methodology. On the one hand, it pertains to cases where a block page is served and where we have added the fingerprint of the block page to our database, thereby enabling us to automatically detect all cases of website blocking based on the fingerprints of that block page. And we also automatically confirm the blocking of websites when we see that an IP address is returned that is known to be associated with implementing internet censorship. If, for example, that IP address hosts a block page. So to see all the most recently confirmed blocked websites based on OONI Probe testing, all we need to do is click Filter Results. And in doing so, we can now see some of the most recent OONI Probe test results from around the world where the blocking of websites is automatically confirmed. And from these rows, we can see that we have examples from Russia, from Myanmar, from Iran, and elsewhere. Cases that are automatically confirmed blocked are annotated with red on the side, and there's also this confirmed label on the side. But not all ISPs around the world implement censorship in this way. In fact, in many cases, we see that the blocking of websites is implemented through the use of a variety of different censorship techniques, such as through DNS-based tampering or TCP/IP blocking, or by resetting connections, and many other censorship techniques. For all those other censorship techniques, which we are not currently able to automatically confirm, but for which we still do have data, you can find those cases by selecting anomalies, where anomaly is used as a term to annotate cases where websites present signs of potential blocking and may in fact contain evidence of blocking, but it's important to remember that there might also be some false positives. So to find such cases, all we need to do is select anomalies and click Filter Results. We can now see various cases where the testing of websites has presented anomalies around the world in different countries. For example, we can see that in Russia, the testing of Twitter.com presented an HTTP failure. To understand these cases better, it might be useful to start off by selecting a specific case study. So let's choose Russia, and I will choose Russia because we know that they implement censorship using a variety of different types of censorship techniques, which can be useful for the purpose of this demo. So we have selected Russia, and we have selected a confirmed blocked website and filtered the results. And now what we have is only the results pertaining to confirmed blocked websites from Russia. If we select one of these, for example, if we select bbc.com, what we see is that, similarly to as was described before, the measurement result starts off by providing a key overview of the finding. In this case, it is telling us that when bbc.com was tested in Russia on this specific network on the 31st of March 2022 at 10 a.m. UTC, it was automatically confirmed blocked. And this is annotated also with a red header. If we scroll down on this page, we can learn more, and we can find the details as to why and how the OONI probe test determined that bbc.com is confirmed blocked in Russia. So what we can see here is that OONI probe started off by doing a DNS lookup to see which IP addresses are mapped to bbc.com. And we see that the DNS lookup returned these specific IP addresses. Then OONI probe tried to connect to these IP addresses, and we can see that all attempts to connect to these IP addresses were successful. Then we can see that once we have connected, we then did an HTTP request in order to get back the content of BBC. But what is interesting to see here is that in the HTTP request, instead of requesting bbc.com, instead we have this other URL. Let's copy this URL and open it in a browser to see what it is. As we can see, this is a block page. This is exactly what a user on this specific network in Russia would see when attempting to access bbc.com. So instead of viewing the content of bbc.com, they instead see this page, this block page, which informs them that access to bbc.com is intentionally censored based on the federal law on information technologies, and protection of information. This in itself is evidence of censorship. We can very clearly see that access to bbc.com is intentionally blocked on this network in Russia. And if we scroll further down, we can see the block page that we just saw also in the response body, as is annotated here in Russian in the page, where instead we should be seeing the content of BBC. If we go further below, we will be able to also then access the raw measurement data. We can also see in the response body that, again, that there was an empty body. So in the raw measurement data, again, you can download it in JSON format. And if you extend the test keys, you can then explore further, where you see that as part of the DNS experiment, it was consistent. We got back the expected IP address. However, as part of the HTTP request, we instead did not get back what we expected to get, because instead we got back this URL, which is not BBC. And as a result, we can see that we then were not able to access the intended website. Now we can have a look at some examples of anomalous measurements. If we go back to Russia, we select Russia, we select web connectivity to limit the results to only website testing, and then we can select anomalies. And once we've selected anomalies, we can click Filter Results to limit our results to those collected from Russia and which presented anomalies. Now, one thing that's worth highlighting is that in anomalous results, we see they're annotated in orange, and we see many different types of labels, where they say HTTP failure, DNS, they might say TCP/IP, and so on. Essentially, these labels here annotate why exactly the experiment presented an anomaly, rather at which point of the experiment there was a failure, which presents a sign of blocking. If we were again to look at any type of measurement from here, for example, if we were to look at bbc.com to see how it's blocked differently on different networks, we can do that by going to the domain area and typing the domain of BBC. Be sure that the way that you type the domain is accurate, and if you're not sure, you can check it from a web browser. Now that we've added bbc.com, we can filter the results in order to only get anomalous or blocked measurements pertaining to the testing of BBC. So first we have some measurements where the testing of bbc.com shows us that it's confirmed blocked on several different networks. We see this, for example, on AS3216, but also on other networks, as you can tell from the different numbers. But on other networks, we see that instead of it being confirmed blocked, we see that it is presenting an anomaly. In this case, DNS, in this case, it's presenting HTTP failure, and so on. If we click on this row here, where it says DNS, to see what is happening, what we can see here is an anomalous measurement. Again, at the start of the measurement page, we have an overview of the finding. In this case, it is telling us that when bbc.com was tested in Russia on this specific network, on this specific date and time, it presented signs of DNS tampering, and therefore it's potentially a case of censorship. But the reason why it's annotated as an anomaly as opposed to confirmed blocked is because false positives can occur. So let's have a look at the actual data to understand whether this is a false positive or whether it may be, in fact, a true case of blocking. First, what we can see is that as part of the DNS lookup, we get back this IP address. Since we know that the specific experiment presented signs of DNS-based interference, since it tells us that it showed signs of DNS tampering, this in itself is a hint that we should be looking at what happened as part of the DNS lookup to see, in fact, if there was DNS-based tampering. So we got back this IP address. How about we access this IP address from a browser to see what we get back? And what we can see is that this IP address also hosts a block page, but a different one in this case. So what this means is that when an internet user in Russia tries to access bbc.com from the specific network, instead of viewing the actual content for bbc.com, they instead see this page, which informs them that access to the website is blocked. So this shows us that, in fact, this is not a false positive, and that, in fact, here we have a case of DNS-based tampering, because what is happening is that the ISP is returning the wrong IP address. They're returning an IP address that is hosting this blog page, and in doing so, they're preventing internet users on this network from accessing bbc.com. And if we scroll back down in the response body, we can see, in fact, the blog page, where here the text is the same as the one that is here. And we can actually see from the data itself what the internet user would see instead of the actual page. And if we scroll further down, we can access the raw measurement data and download it in JSON format. If we expand test keys, we can see that as part of the DNS experiment, we see that it was the DNS was inconsistent. By inconsistent, we mean that the IP address that was returned from the local network in Russia was different from the IP address we got from the second control non-censored network. And so this already shows us that there's a sign of DNS-based tampering. And if we expand on queries, we can explore further. And we can see here that the IP address that is served on, that is returned from this network is 77238, so on, is basically the same IP address that we added here, that we got from above. So this data clearly shows us that while from a non-censored network, a user is able to access bbc.com, from this particular network, the user is not able to access bbc.com because their ISP gives them the wrong IP address. They give them an IP address which hosts a blog page. And very similarly, you can explore the testing of websites around the world. And you can do that by filtering based on web connectivity, choosing the country of your choice, limiting your search results to either confirmed, blocked, or anomalies, where in anomalies you can find many more cases of blocking. And also you can limit your search based on a particular domain.